Okay, in this video we will be learning all about the LDR. So I am in the Tinkercad platform, so it allows us to simulate the LDR. So we will go step by step into the details and see how this device works. So this is a 2-pin device, as you can see here. It's a very simple device, and what you need to learn is that this device is a light sensitive device. You have to understand that this device is some kind of a device that is sensitive to light. So that is the important part here, right? So it has two terminals. There's no polarity for this device. It's a very fascinating device, right? So what happens is, like, the resistance LDR, right? LDR stands for light dependent resistor, LDR, right? So light dependent. So that means that the resistance value depends on the light, right? So it depends on the light. So usually it's denoted by two arrows coming this way, or if it is like the standard symbol, it will look like this, right? So this is the symbol for the LDR, right? So there's one variable called light that affects the resistance. So simply speaking, if you have an LDR and if you connect an ohm meter, you know the ohm meter, right? Ohm meter is used to measure the resistance of a device. So if you have an ohm meter like this, right, what happens is, when you shine light to this device, the resistance will vary. What do you think? When light is high and low, light high means what? What do you think? Resistance will go up or down? Resistance should go down, right? So when there's high light, usually the resistance will decrease, right? We can do some experiments and see how this works. Similarly, the other way around, when light is low, the resistance is high. Okay, so measured across the two pins of this device. So that's what we are going to see in our experiment. Hope that will be very easy to understand once we do the experiment. Right, so let's go to the Tinkercad platform, and what we need to do is simply measure the resistance, right? So I took this component from the basic list of components. Basically what you need to do is scroll down and drag and drop this component to your workspace. Once you have that, you can also drag and drop a multimeter. Right now we are interested in measuring the resistance. So for the multimeter, you can change the mode to resistance, as we are going to measure resistance, right? And connect the LDR using wires like this. Okay, once you do all this, now our circuit is ready, right? So this circuit is equivalent to the diagram that I drew here, right? You know how to connect, right? So this is the LDR with its two ends, and we have to shine light to this device, and we have an ohm meter denoted by the ohm symbol inside this circle, right? So that is what we are trying to experiment with. All right, so let's see what happens now. When we do this, and when everything is ready, what we do is we click on this start simulation icon. So I highly encourage you to create a Tinkercad account, because it allows us to simulate all these components, right? it's very easy to simulate a circuit and test your circuits when you create a Tinkercad account, right? So you click on the start simulation icon. Okay, right now we see a resistance value of 180 kilo ohms, right? 180 kilo ohms. So when you click on this device, right? Let me move this one to the side. So I need to first stop the simulation. Let me move this to the side and click on start simulation. Can you see when I click this one, you can vary, right? You can vary the resistance of the LDR by shining light. So when you move this slider towards your right, it means that more light is shining on the LDR. If you have a real LDR, you can do the same experiment with the real LDR. Just connect your multimeter across the two leads and set the mode of your multimeter to measure resistance. When there is highlight, you can see that the resistance is around 506 ohms, right? When there's no light, see the resistance drastically increase to the kilo ohms range, and we can see a resistance value of around 180 kilo ohms, right? So here it is ohms and here it is kilo ohms. Can you see the magnitude increased, right? So with this we can vary the resistance, right? So you know that 506 ohms is the lowest resistance of this device, right? So can we like connect an LED? How can we connect an LED and see the result? Let's see how we can do this, right? So you know that when there is enough light, right? What is the lowest resistance value that we found for this device? Lowest resistance value, resistance is around 506 ohms, right? 506 ohms. This is the lowest resistance for this device, right? So if you have worked with LEDs, you know that we need a resistor to protect the LED from high current, right? So usually we can use a resistor of around 330 ohms or so uh, for a voltage of, let's say, less than 10 volts. You can use this value safely. I'm not going into details of how this value is computed, but I hope that you know we cannot connect an LED directly. You cannot connect an LED directly to the power supply. You cannot do this. Why? Because the working voltage of the LED might be around 1.8 to let's say 3 volts, but usually your power supply will be 5, 6 or 12 volts, I don't know, but usually it will be higher than this, right? So in that situation, to make sure that we operate the LED safely, we always need to add a resistor in series with the LED, right? So what happens is like the power supply voltage, let's say Vs, right? There will be some kind of a voltage drop. We will put that as VLED and VR for the resistor, right? Across this resistor. So as this is a semiconductor device, most of the time, or almost all the time, right? The voltage drop across the LED will be the rated voltage of this device because this is a diode, right? So it will always have the forward bias voltage drop of around 1.8 to 3 volts. So Anyway that will be a fixed value. So let's say the working voltage of this LED, let's assume that VLED is 2 volts. Then what happens is VLED is 2 volts, so Vs is there. VR, what is VR? VR is equal to supply voltage minus 2 volts, right? So that is VR. So if the supply voltage is 5, VR will be 5 minus 2, equal 3 volts, right? It basically adjusts itself based on the power supply voltage and the voltage drop across the LED, right? So that is a very important concept that you need to understand, right? So let's see how we can add an LDR and see the impact of the LDR on the LED, right? So we already know that when there is light, the resistance will decrease. When there is no light, the resistance will increase, right? We need to see this impact. So what? Let's see how we can modify the circuit diagram in order for us to observe this change, right? So what I have is an LED, right? So the basic circuit diagram is like this, right? LED is there. As we experimentally found that the lowest resistance of the LDR was around 506 ohms. It is safe for us to put the LDR in series. So we do not require an additional series resistor because our LDR is acting like a series resistor and its lowest value R low, let's say, is around 500 ohms, which is perfectly safe. And we have to make sure that our power supply is maybe less than 10 volts, right? Let's put a power supply of around 10 volts and it should be perfectly fine, right? Right, 10 volts. So mostly like the current flow through this circuit should be maybe like limited to something less than 10 milliamperes, right? So that is the condition. But let's see the impact first, right? Let's not worry about the calculations, but let's see how this works first. All right, so let's put 10 volts here. We will apply 10 volts to the LED through the LDR, and we will vary the light falling on this device to see what happens to the LED. So there are two cases here. What happens, like light, we have light and LED brightness. Okay, let's consider the impact. Okay, when there is when the light intensity is high, what happens? The resistance of this device, what what happens to it? When there's more light, the resistance will decrease, right? So R goes down. So R goes down is means that the overall current in this circuit will increase, right? I will go up. So when there is more light, resistance goes down and the current goes up due to the resistance being low. As a result, the LED brightness will increase. So what's going to happen? When the light is low, resistance of the LDR goes up, causing the overall current to go down. Why? This is a series circuit, and you know that current flow in a series circuit is the same through all the components, right? So the brightness should go down, right? So this is what we should observe when we do the experiment, right? So let's build this circuit and see whether that is going to happen, right? So let's stop the simulation for now let's take this out. So what do we need? We need an LED. We already have the LDR, right? And also we need a battery or some kind of a power supply. We can use the 9-volt battery. So positive, right? Remember that the cathode and the anode must be connected appropriately, otherwise this will not work, right? So you know that cathode and anode, you know how it works, right? uh, for the LED to light up, let's put a resistor here just to show you. Anode denotes the positive, right? And cathode denotes the negative, right? So let's put the resistor onto the anode, and cathode will be connected to the ground. And let me change the wire color, and if I run this simulation, it glows. Why? This is a diode and it allows the current to flow, right? Remember that is very important. So here if you look at this symbol, right, this side is the cathode. Cathode means the negative side, right? Negative. And this is the anode, right? Anode will be positive. All right. So current always flows from positive to negative, okay? This way and this way, right? So if you connect it the other way, if you connect the power supply, so this one should be connected to the positive terminal of your power supply, and this side should be connected to the negative side. If you connect it the other way, this LED won't light up, okay? That's really important. So that's what I'm going to show you next. So here you have the LED and the resistor, right? Here basically we have a 1 kilo ohm resistor, but it can be something less than that. We are not going to go into the calculations. We will worry about the calculations later. I just need to show you what happens when we change the polarity, right? So instead of like connecting, let me remove this wire. This time I will interchange cathode. I will connect it to the positive like this, which is wrong, but anyway let's connect it. This one will be connected here. If you run the simulation now, it won't light up. Why? Because LED is also a diode. You know that diode is a semiconductor device that only allows the current to flow in one direction. So that's why when we connect the anode to the positive and the cathode to the negative, the LED will light up. Simple as that, right? You have to remember that. Okay, right. So we are not interested in lighting up LEDs, but we want to see the impact of the LDR on the LED. So let's do that, right? So we found out that the lowest resistance of the LDR in this situation is around 506 ohms. So here is the cathode, right? This is the anode. So we can wire the LDR to the anode or the cathode, it doesn't matter, but to keep certain things easy to be referred later, let me mirror this component now. This one will be the anode and this one will be the cathode. You know that cathode should be wired to the negative. So let me change this one to black, and again I will change this one to red, and here I will wire the anode through the LDR like this. Alright, so let's start the simulation. You can see that the LED is faintly glowing, right? because the amount of light is low. When the amount of light is low, the resistance of the LDR is very high. So the current flow in this circuit will be small, right? So when I increase the amount of light that falls on this LDR, the brightness of the LED increases. Why? The resistance of this device decreases, so the overall resistance of the circuit decreases, causing more current to flow through the LED. As this is a series circuit, the current in a series circuit will be always the same. So when I increase the light, can you see more and more current flows, so the LED gets brighter. So this is what happens with the LDR. Okay? So what are the use cases of the LDR? LDR can be used to create light sensitive circuits, right? To limit the current according to the uh, light. LDR, basically LDR is a sensor, right? It's a sensor. It's used as a sensor for detecting light. Understood? All right. So very useful. So it's available in many devices, right? Maybe the street lighting. Sometimes we will be using photodiodes sometimes to detect infrared light, but this is for visual light. So visual light can be detected by using an LDR or a light dependent resistor, right? So there's many use cases, and this LDR can be easily paired with the bipolar junction transistor to make light sensitive circuits. We will discuss about these things later, but for now I just want to keep this lesson very simple and very easy to understand, right? So this is how we use the LDR simply to control the brightness of an LED, right? So I hope that you learned something out of this video, and if you're not subscribed, please do subscribe for many interesting experiments and lessons. And thank you very much for watching, and I